Hello everyone, in this video we are going to discuss the solution for matrix cell in distance order. So let's see what the question says. Okay, so in this question we have been given our four integers. First two integers are representing rows and columns of a 2D matrix. Number of rows and columns for a 2D matrix, and last two integers are telling me coordinate of one of the cells of this 2D matrix. So had 2 into 3 matrix, so I have made that matrix, and now I have been given coordinate for 1 comma 2. So here it is, this is my 1 comma 2. Now what we need to do is we need to calculate the distance from this given for from this given cell to every other cell, and we need to sort all the coordinate according to this distance, and we need to return all the cells in the sorted order by their distance. Coordinate of all cells in the matrix sorted by their distance from this point. Okay, so this question is very simple. All right, so let's see how we can do this. So first of all, we need to calculate distance. So here we are going to calculate Manhattan distance, which is R0 plus, oh sorry, R0 minus R1 modulus and C0 minus C1 modulus. So this is my Manhattan distance, and that's what we are going to calculate. According to this Manhattan distance, we need to calculate this distance and try to sort them according to this distance. Okay, so this is the formula for my distance. Okay, so now what is R0, R1? Let's say I have point A whose coordinate is R0 and C0, and my coordinate for a point B is R1 comma C1. So if I want to calculate Manhattan distance for these 2 points, this is going to be the Manhattan distance for these 2 points if the coordinate are R0, C0, R1 and C1. Okay, so that's about the Manhattan distance. Right, now let's try to calculate that Manhattan distance. Okay, so let's start from this point. Manhattan distance will be 0 because this is the same coordinate. So distance of this coordinate from this coordinate is going to be 0. Now let's move forward. This distance is going to be 1. This distance is going to be 1. This distance is going to be 2. Remember, we are calculating Manhattan distance, not the direct distance. All right, again for this as well, the distance will be 2 and this distance will be 3. Can you see we are doing something like the binary breadth first search, like this. If you want, you can use breadth first search to calculate the distance and sort them. Actually, this will be much more efficient than sorting entire thing after calculating all the distances. But as this question is part of our sorting module, so we are going to use sorting according to this distance and try to come up with the answer. Although you can do this with the breadth first search, but here we are going to use sorting. Okay, as a follow-up, you may try to do this question by sorting. Oh, sorry, breadth first search. We are already doing the sorting, right? Now, we have already calculated the distance, and we have this kind of distance for each and every cell from our given coordinate of one cell. Now we need to put all these in a matrix which is containing coordinate of cell. So how we can do this? So first of all, we have said that this should be the order. The smallest distance from the this coordinate should come first. So 1 comma 2 will come first. Then we have two coordinates having same distance from this point. So which one is going to come first? Actually, any of these two can come first because the distance is already same. But to match our answers, what we are going to do is we are going to give a box number to each cell: 0, 1, 2, 3, 4, and 5, like this. And we are calculating this box number by I into columns plus j. Like this, we are going to calculate the box numbers for each cell, and according to this box number, if their distance is same, we are going to use the smaller box number first. So box number 2 is this, so we are going to put 0 comma 2 first. Remember, it can happen that you may write 1 comma 1 first after before the 0 comma 2, but to match our answers you need to try to put 0 comma 2 first. Although your answer, if 1 comma 1 first comes in your answer, it will be absolutely right, but we are using box number just so that we can match your output with our output. So 0 comma 2 will come first, then will come 1 comma 1 will come after this. What is going to come? This box number 1 with the distance 2, so 0 comma 1. After this 1 comma 0, and in the last 0 comma 0 will appear. So if we will try to match our sample output, let's match it. Okay, so we have 1 comma 2, 0 comma 2 comma 1, 0 comma 1, 1 comma 0, 0 comma 0. Okay, so this is how we are going to sort according to the distance. Okay, so we know how we are going to give the output. We know how we can calculate our output by using some box number and some Manhattan distance. So the question comes is how we are going to create our answer. So first of all, we are going to uh, create a 2D vector for this entire thing, so that we have the coordinate for each and every cell, for cell 0, cell 1, cell 2, cell 3, 4, and 5. Okay, so let's create that: 0 comma 0, 0 comma 1, 0 comma 2, 0 comma not 0 comma 1 comma 0, 1 comma 1, and 1 comma 2. Okay, now we just need to sort this thing according to our what? Distance, Manhattan distance. Correct. So how we are going to do this? We all know only one thing we can use to sort, which is sort function. We are just going to use that sort function on this apparently 1D array. Okay. To create this, we can use a pair class, or we can use vector of vector. In this case, I'm going to use vector of vector because it will be very simple to write. Okay, so this is how we are going to put all the cells coordinate in one array or vector. Okay, so its index will be 0, 1, 2, 3, 4, and 5 according to this box number. Okay, so first let's try to calculate a box number. How many total boxes will be there? As many as there are cells, there will be that many boxes. So we will have rows into column number of boxes. After this, we are going to sort this entire thing using a lambda function on sort. And how we are going to do this? Let's see. So first thing what we were doing was trying to create a vector of vector. Let's name it as answer. Okay, vector of vector answer. How many boxes or rows it should have? Rows into columns times, because that many cells are present. And after this, is storing second part is storing what? R, I and J. So its size will be 2. Okay. Now we need to fill this answer with all the coordinate of our cell. And I equal to 0, I less than J, and I plus plus, or not J, rows. Okay. So this int J equal to 0, J less than columns, J plus plus, and now we are going to calculate box number, which will be I star columns plus J, and answer Bn, which is nothing but this entire thing. This box number is going to store at the 0 position. What is it is going to store? It is going to store I, and in the second part it is going to store J. So at 0 it will store my I coordinate, and Bn1 is going to store my J. So that's it. Now I have this entire thing. I have filled all the cells in one array. Okay, now we need to just sort it using sort function and lambda function. Okay, so let's sort this. Answer dot begin, answer dot end, and that's it. Now we are going to write lambda function. Now first thing we need to do is catch I and C center, because we are going to use it in this lambda function. So we need to catch it from outside. So let's catch them. Now we have R center and C center, and we need to extract a vector of int. Okay, vector of int A, we name it A, and another one B. Now this lambda function is going to return me a boolean value. Now how we are going to get a boolean value? Let's see. Now we were calculating our Manhattan distance for one coordinate, okay, or one cell I should say. So we have a cell called A and a cell called C or B. So let's calculate distance for A from our original coordinate, whose coordinate were R center and C center. So it is going to be ABS, because I have used modulus there. R center minus A0 plus ABS C center minus A1. So I have distance for my A coordinate or a cell called A. Okay, and now we are going to copy paste the same code, because this is the same way we are going to calculate distance with our B. coordinate ourselves. Oh, I put assignment operator. Let's change it, and that's it. We are done. And what this lambda function is going to return? It's going to return the result of d1 less than d2. This false. If this is true, this is not going to sort. If this gives false, then it is. And it means A should come first. If this is sorry, what I should say is if d1 is less, then A is going to come first. A cell is going to come first before the B cell, and this is false. Then it means B cell is going to come first. That's it. Instead of null here, we are going to return the answer vector. So let's run it. Okay, I may have made a mistake somewhere. Answer 14. I forgot to put semicolon. Let's run it again. Okay, I have made another mistake. I have get run instead of return. Okay, let's see if I have made any other mistake. Okay, C center, R center, C center. Okay, I think this should run now. Okay, so it's been accepted for our sample test case. Let's submit it. Okay, we got 10 out of 10, which means we have correct code here. What we did was try to create a vector which has all the cells 0, 0, 0, 1, 0, 2, and 1, 0, 1, 1, and 1, 2. In the sort function here, what we did was try to sort this answer vector using a lambda function. Okay, using a lambda function, what we did was sorting. Okay, and this is the Manhattan distance for our extracted cells, A cell and B cell. Manhattan distance, and according to the Manhattan distance we have calculated, we have just done the sorting. That's it. This is what we have done here. So the solution for this problem has been completed, and I will recommend you to watch this video again if you haven't understood it yet. Also, if you want a follow-up on this question, you can try to solve it using BFS, but after trying it with our sort function along with lambda function. Okay, so that's it for the video. I'll see you in the next video with some new question. Till then, goodbye and take care.